Welcome to this deep dive. We sort through the sources you share to pull out the key takeaways.
Glad to be here.
Today, it's all about STEAM education. We've looked at articles from Resilient Educator, the School of Research Science, and the University of San Diego online degrees.
A good mix of perspectives.
Yeah, and our mission today is to figure out, what is STEAM really? Why is it seen as so important now?
And how it differs from what came before, like STEM.
Exactly. And the benefits, the practical side of it.
Yeah.
Okay, so let's just jump in. What exactly is STEAM?
Okay, so fundamentally STEAM. It's an educational approach. The acronym, as pretty much all our sources say, stands for Science, Technology, Engineering, Arts, and Mathematics.
Right, the basics.
But the really critical part, and the School of Research Science really hits this point home, isn't just the subjects themselves, it's how they're integrated.
Integrated. How so?
Well, it's about bringing them together. Not teaching science here, art over there.
Yeah.
It's interdisciplinary, very hands-on. Think of it less like a subject and more like a framework for designing learning.
Ah, okay. So not just separate classes, but finding where science and art or tech and math actually connect.
Precisely. And letting those connections drive the learning.
And the big idea behind knitting these together, it sounds like, is about building up those skills we keep hearing about for the 21st century.
Exactly. Things like, innovation, critical thinking, definitely creativity, and just being better problem solvers.
Yeah.
That's what the sources really emphasize.
Makes sense.
And the School of Research Science also points out that it's very much driven by, curiosity, exploration.
Thanks on why.
Yeah, encouraging students to ask those questions and then, crucially, to investigate and find answers in ways that connect to the real world.
Got any examples?
They get some good ones. Like students not just learning about robots, but actually designing and building them to solve a problem.
Okay.
Or maybe using art and design principles to come up with solutions for, say, environmental issues.
Right, like making data visually compelling or designing a sustainable product.
Exactly. And the University of San Diego mentioned that Andover High School example, teaching geometry through art.
Oh, yeah, I like that one. Using a museum scavenger hunt with art to understand geometry, it makes abstract ideas feel, well, real.
It really does. Makes it stick.
So it's called STEAM with the A. That suggests it wasn't always like this. What's the history here? Where did it come from?
Good question. Yeah, it definitely evolved. It grew out of the STEM movement.
STEM science, technology, engineering, math.
Right. Our sources point out that STEM got really big back in the early 2000s.
And the push there was...
The main driver, according to both the School of Research Science and USD, was about boosting technical skills, fuel innovation, create jobs in those key areas.
So a focus on the technical foundations, but then something was seen as missing, which led to adding the A.
Yeah, exactly. There's this growing realization that something important was left out. Things like design principles, creative ways of expressing ideas, and even the broader context from the humanities. So both the School of Research Science and USD really stressed that adding the arts wasn't just an add-on. It was a recognition that creativity and design thinking are actually essential for real innovation.
That clicks. You can be technically brilliant, but without that creative approach, maybe you don't get the real breakthroughs.
Right. The University of San Diego had that quote from Georgette Yackman.
Yeah, the STEAM advocate.
She said it's not just STEM plus art. It's about blending the who and why from the liberal arts with the what and how of STEM.
Who and why with what and how. I like that. It grounds the tech in, humanity.
It really does. It's about understanding the impact, the context. USD also mentioned the Rhode Island School of Design, RISD, and their focus on the symbiosis between arts and sciences.
Symbiosis. Nice. They feed each other. Okay, so we know what it is, where it came from, why the big push now. Why is STEAM seen as so vital for students today?
Well, the sources are pretty clear on this. Resilient Educator talks about preparing students for a future that's, heavily based on technology and where the job market is always changing.
Adapting to change.
Definitely. And the University of San Diego brings up that U.S. Department of Education points students need skills to solve complex problems, evaluate evidence critically.
Skills that STEAM directly targets.
Exactly. And it's not just about abstract skills. There was that quote from Michael Milligan.
Right, in the USD article about graduates developing meaningful solutions to societal problems.
Yeah, suggesting a real-world impact. And the NGSS article, the one on standards, points out how STEAM breaks down those old silos between subjects.
Interdisciplinary learning.
Right. Helping students see connections, apply knowledge more broadly, and of course, fostering creativity, thinking outside the box. That's a huge theme.
That outside-the-box thinking feels central. And the hands-on part must be key for building critical thinking, right? Doing versus just reading.
Absolutely. Applying principles to design and build something that, actually works, that cements understanding in a different way.
And presumably helps with careers later on.
Big time. Both the School of Research Science and USD link this directly to preparing students for jobs that need that mixed technical skills and creative problem solving.
Is there data on that?
Yeah, USD mentions U.S. Bureau of Labor Statistics data projecting real growth in STEAM fields. So it's practical, market relevant.
Okay, so job readiness is a big factor. What other advantages are highlighted?
Well, collaboration comes up a lot. Both the NGSS piece and the School of Research Science talk about teamwork on these projects and communication skills that get developed.
Makes sense, you have to work together.
And engagement. Students are often just more motivated when learning is project-based, challenging, maybe even fun.
Less boring than just lectures, I guess.
For sure.
Yeah.
The School of Research Science also lists some specifics: tech fluency, analytical skills, design, systems thinking, teamwork.
Wow, quite a list.
Yeah, and they also mention better college readiness, applied knowledge, critical analysis. It builds a strong foundation.
It sounds really holistic. The School of Research Science even mentioned whole-mindedness. I like that term. Developing a more versatile way of thinking.
Exactly. Essential for things like, say, starting a business or inventing something new.
And it goes beyond just cognitive skills.
Yes, they also emphasize things like ethics, social responsibility, empathy, a global view, the human side.
That's important.
And finally, because students often lead their own learning in STEAM, it builds self-confidence, resilience, the motivation to tackle tough stuff.
Empowering them.
Right, taking ownership.
That's a really strong case. Now, you mentioned students leading their learning. Inquiry-based learning seems closely linked here. How do they fit together?
Yeah, Resilient Educator really draws that connection strongly. They argue inquiry-based learning is a natural fit for STEAM, perfect for fostering that critical thinking and innovation.
And the core idea of inquiry-based is
It's that students are really in the driver's seat. They ask the questions, they investigate to find answers, and then they reflect on what they've learned.
so the teacher steps back a bit, becomes more of a guide.
Exactly. A facilitator. Resilient Educator quotes Dr. Sharon Friesen on the benefits students learn to gather information, critique it, analyze it, form theories, ask more questions, building those core research skills.
And the link to STEAM is the hands-on nature, the problem solving.
Absolutely. They feed into each other. Resilient Educator mentions the Exploratorium's definition of inquiry: exploring, questioning, discovering, testing those discoveries rigorously.
Sounds like how actual scientists and engineers work.
It really mirrors those real-world processes. It's more than just hands-on, it's minds-on, engaging in scientific practices.
Right, I saw that distinction, not just doing activities, but thinking like a scientist.
Yes, and Dr. Robin Gillies, also quoted in Resilient Educator, talks about that investigative approach, grappling with problems, observing, questioning, testing ideas.
And pushing students beyond their comfort zone.
Right. Presenting challenges that force them to rethink things, construct new understandings. It's about that active process of explaining, evaluating, refining.
Okay, this sounds great in theory. But for a teacher listening, how do you actually start with inquiry-based STEAM? Any practical tips?
Resilient Educator offers some good starting points. First, pick topics students are actually interested in, things that naturally spark questions.
Like what?
Could be solar panels, the school garden, maybe the latest apps they use. Things relevant to them.
Okay, start with interest. Then what?
Then outline how they'll explore. What will they observe, experiment with, analyze? How will they refine their ideas?
Setting a framework.
Exactly. And define the learning goals. What should they understand or be able to do after their exploration, both on their own and working together?
That seems doable. Start small, focus on the process.
Right. And Resilient Educator also provides a helpful list of resources, actual lesson plans, project ideas from places like PBS Kids, Microsoft, NASA, museums.
So that's useful. So teachers don't have to reinvent the wheel entirely.
Definitely not.
Yeah.
Lots of great stuff out there to adapt and use.
Good to know. So, looking forward now, what's the future hold for STEAM? Is this trend growing?
It seems so. The University of San Diego article quotes Bernard Marr calling it essential for the fourth industrial revolution. The need for creative problem solving is paramount.
And that traditional learning isn't enough.
That's the argument. Naveen Jain's quote in the same piece says, rote learning won't cut it for complex global challenges. We need to teach how to learn, question, experiment, create.
So it's about building that adaptive, innovative mindset.
Precisely. And the School of Research Science notes this growing awareness among parents, educators, policymakers. They see the need for that blend. Tech skills, creative thinking, social intelligence.
Skills for resilience, really.
Yeah, for individuals and society. Expanding STEAM opportunities is becoming a global priority.
And the School of Research Science example, their own program, focusing on real-world solutions.
Right. Environmental issues, human needs, fostering ethical innovation, empowering young people to make a positive impact. That's a powerful vision for STEAM.
It really is. Not just learning about the world, but learning how to change it for the better.
That seems to be the ultimate goal, developing confidence and purpose.
Okay, well, this has been incredibly insightful. Let's try to quickly recap the main threads here.
Sure.
So STEAM science, tech, engineering, arts, math. It's this integrated, interdisciplinary approach. Very hands-on.
Focused on building those key 21st century skills, critical thinking, creativity, problem solving through real-world application.
And we saw how it grew from STEM, adding that crucial A for arts, recognizing that design and creativity are vital for innovation.
Absolutely. And the strong connection with inquiry-based learning, putting students in charge of their discovery process.
Right. It's clear it's more than just the latest education buzzword. It feels like a pretty fundamental shift.
Yeah, preparing students not just to cope with the future, but to actively shape it, giving them the skills, the mindset, and that human-centered view.
So a final thought maybe for you listening in. How could these STEAM principles, that integration, the creativity, the critical thinking, the real-world focus, apply in your own life, your own learning?
That's interesting.
What new connections might you make if you looked at challenges, even everyday ones, through that kind of multidisciplinary lens? Something to think about.
Definitely food for thought.
Thanks for joining us on this deep dive.